the heart, all of the aspects of the heart, all of the little things that you have to learn about the heart. And it's never going to stop. If you do have a lab today, obviously you see what's on the board there. Wait till you get to that, because in itself it's intimidating. Now, the different aspects of the heart, one thing I want to point out to you guys before we start rolling through this stuff is this right here. This looks gigantic. It's huge. It's gigantic. It's the aortic arch. It's actually not that big. When we dissect hearts on Thursday, you're going to find out that this pulmonary trunk is twice the size of the aorta. The pulmonary trunk is twice the size of the aorta. So the aorta, everybody makes it look like or sound like it's this gigantic, huge, amazing, out of control, huge thing. It's not. It's actually quite a bit smaller than the pulmonary trunk. And the reason why is because the pulmonary trunk has to be high volume, low pressure. High volume, gigantic tube, very super short, low pressure. Okay, and to put this into perspective for you, think about it this way. If you have a straw, like a bubble tea straw, and you put it in fluid and you draw on it, the fluid goes through really super quick. Now let's take a coffee straw, you know those little tiny fine coffee straws, little tiny thing, and make it 100 feet long. How much effort would it take to draw the coffee through that? A lot. So it's the same thing. Remember, the aorta is going out to the entire body, so it's super, super long. So it's got a lot of pressure. As where the pulmonary trunk is just going from here, literally from here to here. That's it. That's the distance. From the heart to the lungs, that's it. And it's big, it's huge. So there's the difference. And you guys will see that tomorrow. You'll see it tomorrow Thursday when we dissect hearts. Okay, that's kind of what a heart looks like. That's preserved, really preserved. All right. Right ventricle, free edge attached to the chordae tendineae. Chordae tendineae, so tendon, cord-like tendons. Chordae tendineae from the papillary muscles of the ventricle. Prevent the valve from opening backwards. Okay? So, what they're saying is, heart, valve. Okay, see our flaps going down? The chordae tendineae are attached to those flaps and then to muscle, to the papillary muscle, like this. So, remember, what pushed those flaps closed? If we're flowing this way, what's pushing them closed that way? Pressure. The contraction, pressure. Well, in order to keep these from doing this, flap, you have these chordae tendineae and papillary muscles. So literally, when the ventricles contract like this, so do those muscles. And they keep the flaps down. Because if you didn't have those, the flaps would just turn back up into the atrium, and the blood would go back the same direction it came from. So when it says the chordae tendineae form papillary muscles of the ventricles, it's literally pulling down on them. It's preventing them from flapping back up. Okay? It's preventing them from flapping back up. So in this case, the chordae tendineae and the papillary muscles pull down, the flaps stay down, but then the fluid pushes up on them to close them. Okay, now chordae tendineae is also used in a generic form. A generic form. Really super generic. Okay? Yeah. Anybody remember what the generic form is? I think here, a demonstration of this would be better. Okay, let's come over here. Hello, Roberta. Everybody, Roberta, this is everybody. Do you have a special someone in your life?
Yeah.
She does. Oh my gosh, look, she's flushing up. Oh my gosh. Does he pull on your heartstrings? Just tugs on your heartstrings, doesn't he? When he gives you a flower or something like know, just tugging on those heartstrings. Yeah, have you guys ever heard that before? Tugging on someone's heartstrings, like you see a little baby puppy, and it's like, oh, weighed heavy on my heart, it pulled on my heartstrings. That's what they're talking about right there. The chordate tendon, okay? And I'm pretty sure that Roberta's going to kick me in the shin when she walks out today. She'll be like, thanks, Phil. But deep down inside, we all have that special someone that pulls on our heartstrings, right? And they wink at us a certain way, or they smile at us a certain way. Yeah. Right atrioventricular valve, also called the tricuspid valve. Okay, so what's the other side called then? Bicuspid valve. Has 3 cusps, prevents backflow, Okay, right ventricle, trabeculae carneae. Okay, muscular ridges on the internal surface of the right and left ventricle. Okay, ridges contain part of the conducting system, not all of it, just part of it. And Kerpow, there's your chordate tendonae, there's your papillary muscles, and when you're in love, boy, those babies are just being tugged on. Because we know that your heart's not beating 65 to 75 beats per minute. When you're in love, and spring is in the air, your heart's doing this. Yeah, date night. Oh, so beautiful. Titanic. Yeah. No, I got to use a different movie, right? The Notebook. Yeah. Okay, pulmonary circuit. 50 Shades.
No.
Yeah, no, that's not pulling on heartstrings. That's like ripping arms off. That's something else. Because I guess that is the new movie, huh? If you got your special someone to watch that with you, woo-hoo! We don't want to talk about that. Okay? Pulmonary circuit, well, it leads to the pulmonary trunk. Pulmonary trunk divided into left and right pulmonary arteries. Okay? Right and left pulmonary arteries. Well, the pulmonary arteries are circulating deoxygenated blood. So remember when I said that the heart has a lot of rules that it breaks? Remember the apex was at the bottom and the base was at the top? Yeah. So in this case, the pulmonary arteries are carrying deoxygenated blood, and the pulmonary veins are carrying oxygenated blood. So it's backwards. The only true statement we can make is this: arteries leave the heart, veins enter the heart. Let me say that one more time. Arteries leave the heart, veins enter the heart. The type of blood they carry can be off because pulmonary arteries carry deoxygenated blood. No oxygen. Now, there is some, but very little. Okay? Well, let me back up here. Let me see. Okay, so it says blood flows from the right ventricle to the pulmonary trunk through the pulmonary valve. Here we go, and let's do it in blue. Pulmonary valve right here. And that pulmonary valve actually has another name. It's called the pulmonary semilunar valve. Pulmonary semilunar valve. Okay, did I mention semilunar to you guys yesterday? Okay, semilunar is also abbreviated SL. So we have AV, atrioventricular, and then we have SL, semilunar, and it's the shape of it. And notice it says right there, semilunar cusps. It's the valve. There's 3 semilunar cusps. Now, right now I'm going to talk to you guys about it being a semilunar valve. It's the pulmonary valve. Then we have the atrioventricular valves. But as we move on, I will not actually address them as the tricuspid or the pulmonary semilunar. I will actually address them as this: the AV or the SL. And the reason why I'm going to give up their exact names and start going with AV and SL is because of flow of blood through the heart. All right? So we go down the AV into the ventricles, then we go through the SL into the pulmonary trunk and the aorta. Okay, so see how easy that was to just get rid of their exact names and say we're going down through the AV and up through the semilunars, the SLs? Okay, and the reason why I do that is because when we actually start looking at flow of blood through the heart and sounds it's making and everything else, they're going to refer to them as AV and SL also. They're not going to refer to them by their exact names. So just be prepared for the abbreviation of those. So pulmonary valves have 3 semilunar cusps. They go into the pulmonary trunk or the aorta. Actually, they're called aortic valves. So left atrium, blood gathers into the left and right pulmonary veins. This is oxygenated blood. This is oxygenated blood. Pulmonary veins deliver to the left atrium. Blood from the left atrium passes to the left ventricle through the atrioventricular valve, the AV valve, which is also named the bicuspid because it has 2 cusps, or the mitral valve. Then we go into the left ventricle. Okay, it is larger, more muscle, more powerful. Similar internally as the right, but has more moderator bands. Now, is that going to be huge for us? No, actually, what's huge for us is the fact that it has a lot of muscle. It has a lot of muscle. Because it has a lot of muscle, you need to know that. The left ventricle has more myocardium than the right. So, systemic circulation, blood leaves the left ventricle through the aortic valve, also known as semilunar. Ascending aorta. Ascending aorta turns aortic arch and becomes the descending. So, up, arch, down. Okay, and then back to this image. So I'd like everybody to take this out. Okay, Susan, I've got one for you. Hold on. And I need to train you, Mimi. All right, so as a somewhat kind of joke, okay, we'll go after my. Kind of joke, please tell me what women boast about being able to do all the time. Like, they look at men and like, Muhammad, and they say, we can always do what? It's something about doing multiple things at the same time. Multitasking. Yeah, I know. Muhammad, you're with me. Aramis with me. It's all about, we don't know how to multitask at all. Not at all. You know what? I can turn the television channel, drink a soda pop, and eat my hamburger all at the same time. So I'm pretty good. Right? It's good. Right? So, interestingly enough, let's do this. Starting from this image, that starts off with this heart, and I know they probably did this. If you, ladies, were multitasking, you would have done this. Step by 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 step, all the way through number 14. Because that's exactly what we just did. So how many people actually filled those in as we went through them? One person. Two. You did it? A few questions? Okay. We just went through number 14, step by step. by step. You were thinking. Okay, thinking's good. Thinking's good. Yeah. Now, I know that Aramis and Mohammed already did them. They were already done. Ah, that's right. So, guess what? One for the guys. Sorry, ladies. Sorry. Yeah, that was all of those slides that I just went through, all of these slides, from this image to that image was the flow of blood through the heart. Now I'm just picking on you gals. I know some of you were doing it. It's okay. All right? But, step by step. So during today's lab, guess what you're going to have to do? Step by step, all the way through. Okay? So, structural differences between the left and right. Well, obviously there's a heck of a lot more. A heck of a lot more myocardium on the left. Okay, right ventricle wall is thinner. Develops less pressure than the left ventricle. Right ventricle is pouch-shaped. Left ventricle is round. We're forcing a lot of blood out of that left. There we go. There's the difference between the two. Okay, notice all the myocardium around the left. Huge force of contraction. Huge force of contraction. An amazing force of contraction around the left ventricle. In fact, I'm surprised at how much force of contraction is found around that left ventricle. All right, so look at the dilation and the contraction of that left ventricle with the myocardium and that force of contraction. All right, the heart valves. Well, 2 pairs of one-way valves prevent backflow during contraction. 2 pairs of one-way valves, AB and SL. AB and SL. So, 2 pairs of one-way valves prevent backflow. Atrioventricular valves between the atrium and the ventricles. Blood pressure closes the valves during ventricular contraction. Let me say that one more time. This is physiology now, not anatomy. So if your brain's on anatomy, switch gears to physiology. Blood pressure closes the valve cusps during ventricular contraction. So during ventricular contraction, the blood pressure increases, closing the valves, the AV valves. So here we go. Squeeze, contract. Squeeze, contract. And when we contract like this, we close the 2 AV valves. Well, if there are 4 valves, 2 pair, here's 1 pair, and here's the other pair. There are 4 valves found in the ventricles. Okay? These are leading from the atrium to the ventricles, and these are in the ventricles going to the lungs or the body. 4 valves. So, let me do this one more time. Squeeze, contract. And if we're closing the AV valves on contraction, what valves are being pushed open? SL. If we're closing the AVs during contraction, ventricular contraction, we're pushing the SLs open. Simultaneously, right at the exact same time. So squeeze as hard as we can. These 2 valves, AV valves close, these 2 SL valves open, and the blood goes up. So it was no surprise that I actually used this. Squeeze, contract. Because that's exactly what happens. Okay? Now when you guys are walking through the hallway doing this, don't poke someone's eyes out. Don't be like, squeeze, contract. Okay? You're not an Avenger. You don't need to whack them out with your heart contraction skills, your superpowers. Okay? But yeah, we're talking about closing 2 valves, the AVs, and opening the SLs, all at the same time. Now, just what I mentioned, it says pressure closes the valves, but papillary muscles tense the chordae tendineae to prevent the flaps from flipping up. And that is called prolapse. Okay, a prolapsed valve. A prolapsed valve. It flips them open. And it actually can cause major, major problems with people. And usually what happens is either the muscles or the chordae tendineae fail. The muscles of the chordae tendineae fail, and those flaps swing back open. And that's what I was showing you right here. See how the flaps are just kind of flipping up? That's what we don't want. We want to get rid of that, and we want them to stay as nice as possible, like that. We want those valves to be down, not up. Any questions? All right. 5 more minutes. So, heart valves, semilunar valves, pulmonary and aortic tricuspid valves, prevent backflow from the pulmonary trunk in the aorta into the ventricles. No muscular support, 3 cusps support like a tripod. So, here we go. Blood, we're in the atrium, squeeze, we go through the AV valves, okay, ventricles, contract, we close the AV, we open the SL. We go up like this out to the pulmonary trunk in the aorta. For a brief second, the blood does this. It backs up a little bit. And when it backs up a little bit, what does it close? The SL. So squeeze, close. Squeeze, close. Just a little bit of blood, not a lot, just enough to push on those cusps and close them. Okay? So we'll have a brief moment of actual really high pressure. We'll have a brief moment of high pressure when that blood backs up to close those valves. Aortic sinuses, okay, at the base of the ascending aorta, sacs that prevent valve cusps from sticking to the aorta, okay. Origin of the right and left coronary arteries, okay. So a little area so the valves don't stick, and there you go. Notice the aortic valve right here. So see how they're all disc-shaped? There's 3 cusps and they're disc. We're looking down. And because they have a disc like this, actually let me go on the board, they actually have cups. There's a cup, and there's a cup, and then here's a cup. And so when the blood backflows, what does it do? It puts pressure on those cusps and stops them. So let's just do it 2-dimensional. If we do this, okay, blood will flow up like this, and for a brief second it'll come back and close the valves. So up through the valves and then push back down, but there's 3 of them, not 2. And they're not butt-shaped, because that's weird. Okay? There's 3 of them. Go ahead.
On the previous slide, it said that it was aortic sinuses at the base of the ascending aorta.
Uh-huh.
Is that like the bottom of the aorta or the...
Okay, so the aortic arch does this.
Yeah.
So right at the beginning of the aortic arch where this valve is, there's a little sinus. There's an opening. And it's a pouch-like area. So when the valves push up, they can actually come back down. Yep. Right at the base of it, it's just like a larger area. Okay? So they push up through, and then the blood, when it comes back down, pushes them close. No strings, no muscles, no nothing. We're good. Where are the strings, the heartstrings found? AV valves, yeah. AV valves. Okay, so notice what's happening here. Left atrium, through the bicuspid valve, down into the left ventricle. Okay, notice the chordae tendineae are loose, the papillary muscles are relaxed, the left ventricle is filling with blood, and then pow! See what's happening with those valves? They get pushed open, and then if the blood flows backwards, what happens to them? They just seal. That's it. They just seal. Crazy looking, huh? So there you go. Contraction of the left ventricle. Chordae tendineae are being pulled tense up at the bicuspid, but nothing going on here. We're just pushing straight out into the aorta. And back to your question, there's the sinus. See this large area right around it?
Mm-hmm.
Yeah, that's where it's at. It's just so that when the valves flip open, they don't stick to each other, and they can come right back down. Now do I have any questions? Okay, you have to know the flow of blood through the heart. You have to. Like it's second nature. Like it's getting into your car, putting your key in the ignition, turning the ignition. Okay? Can you just drive off at that point? No. What do you have to do now? You have to put your foot on the brake. You have to put the car in gear. Okay? You have to look both ways. You have to pull out. You have to signal. You have to do all these different things. Now, some of you are wild and crazy in your car, and you don't do systematic steps to drive. Okay? Which is weird and scary at the same time. But think about all the things you have to do. Okay? You can't just say, I get in my car and drive. No, 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 no. You have to be methodical. I unlock the door. I open the door. I get in. I close the door. I put my seatbelt on. I put the key in the ignition. I turn the ignition. The car starts. I put my foot on the brake. I put the car in gear. I turn the steering wheel the way I'm going. You have to be methodical. You can't just say, I get in my car and drive, because your heart just doesn't pump. You have to know every single little detail. Okay? Questions? And not about your driving skills. All right. Connective tissue and cardiac skeleton. Well, connective tissue fibers physically support the cardiac muscle fibers, distribute force of contraction, add strength, and prevent overexpansion of the heart. This is the covering of the heart. This is the connective tissue that covers the heart, such as epicardium. You guys remember that? Pericardium, the visceral and parietal layers of the pericardium. You should remember that because that was at the beginning of this set of slides. What they're saying is they add strength to the heart. It helps prevent overexpansion. Provides elasticity that helps return the heart to its original size and shape after contraction. It's like a pair of spandex, right? You grab them, you squeeze into them, and you let go, and what does it do? And you're like, yeah, looking pretty firm, right? What do you think this sac covering the heart is doing? Holding it in place, giving it a little strength, helping return it to its original shape, preventing overfilling. Now, the cardiac skeleton, 4 bands around the heart valves, okay, in the base of the pulmonary trunk and aorta, stabilize the valves, electrically insulate ventricular cells from the atrial cells. And when we're talking about the conduction system, we're going to actually talk about how there's a difference between the two. There's actually a delay. Okay, and that delay's there for a reason. It's my favorite time. You guys don't get it yet, but you will. Okay, that delay in the heart, that little split-second delay in the heart, it's for fill time. That's right. That's a true statement. It's for fill time, and not P-H-I-L, as in me, but F-I-L-L, as in filling with blood. The delay is to help the heart fill with blood. It's called fill time. I know it sounds weird because my name's Phil, but geez. Okay? It is. There's a little delay there, and it actually helps with fill time. It gives it that little extra time to fill up with blood. Now, blood supply to the heart, well, it's coronary circulation. So, if there's coronary circulation, what were the other 2 types of circulation that you guys need to know about? Pulmonary circulation and cardiac will be coronary. Okay, so we've got coronary, we've got pulmonary. What's the other one? Systemic circulation. Please write those down. Okay, there's the difference between 3 things. We've got coronary circulation, which is the heart. We've got pulmonary circulation, which is the lungs. And we have systemic circulation, which is the body. Coronary circulation, we're talking about supply blood to muscle tissue of the heart. Coronary arteries, cardiac veins. We have the sinus that empties into the right atrium. You guys remember the coronary sinus? That, remember, it said 3 things. And you know what? I think it's pick time. Let's pick. Let's pick. Let's start off with Ellen. What is one? One of the three things that empties blood into the right atrium. One of the three things, three vessels that empty blood into the right atrium? Yeah. Well, no, not pulmonary. Into the right atrium. What are the three things, three vessels that empty into that? The right atrium. There are three vessels. I just said one. Three vessels that empty into the right atrium. Okay, remember, that's where it all starts. The superior vena cava. Thank you very, very much. Aramis, what's one more? There are three. She just said superior vena cava. What's one of the other two? Inferior. Inferior. Okay, and Maria, what's the last one? I just mentioned it. We're talking about coronary circulation, so it would be the coronary sinus. Coronary sinus. Those are the three that empty into the right atrium. Okay? Coronary arteries, left and right, originate at the aortic sinuses. Okay, high blood pressure, elastic rebound force, blood through the coronary arteries between contractions. Right coronary artery supplies blood to the right atrium, portions of both ventricles. Okay, cells of the SA, sinoatrial and atrioventricular nodes. Okay, we're talking about different parts of the heart right now. Left coronary artery supplies blood to the left ventricle, left atrium, and interventricular septum. So what we're talking about right now is just the heart. We're not talking about pulmonary, we're not talking about systemic. We're talking about all the blood vessels on the heart proper. Let's back up. Coronary circulation, we're talking about all the blood vessels on the heart and what they're supplying. So this is telling you left and right, originated aortic sinus, high blood pressure, right coronary artery, right atrium, cells of the SA and atrioventricular nodes, left coronary arteries, left ventricle, left atrium, interventricular septum. Now, here's where we start talking about the names of those vessels. Two main branches of the left coronary artery, circumflex artery and anterior interventricular artery. Okay, here's what I want you guys to do. Stop taking notes for a second. Now, this is really big because there are a few things I do for you guys as a teacher that I want to make sure you guys understand why I'm doing it so that it helps you when you take tests, when you move on to other classes, when you start doing what you're supposed to be doing, okay? And I'm talking about your program. So here's our heart. It is easy for you guys to sit and memorize the different parts of the heart. It's easy to do that. It's just rote memorization. It's not so easy to take multiple concepts and put them together. Okay? I'm not going to do the inside of the heart. I'm going to do the outside of the heart. And if we have a circumflex artery and an anterior interventricular artery, okay, and it says they are part of the coronary arteries, I want you guys to think logically now. They're part of the coronary arteries. They supply blood to the left ventricle and the left atrium. So, let's do this. Meaning, where on this, just tell me to stop when I'm moving my pen, where on this is the left ventricle? It's right here? anatomical position. This would be right ventricle, so it would be where? Right there. Okay? And that's going to be left ventricle. Okay, Susan, where's the left atrium? Right here? Okay. All right. Half the work is done for you now. Lucy, what's this? Right ventricle, yeah. Right vent. Okay. Hamdi, what's this?
Or right, atrium.
There we go. Right atrium. Now, we've got it somewhat mapped out. Okay? Somewhat mapped out. And it says interventricular septum. So, let's just go ahead and logically work through this. I'm going to switch from red to blue. Circumflex artery, not so easy, but the next one, anterior interventricular artery. Anterior, so Maria, you're mapping it out right now, so why don't you help me where that is? Anterior interventricular artery.
Well,
Up
no, maybe
here?
more to the left. No.
No, where?
Go down. Right there.
Right there?
Yes, and go down.
So right here,
Yeah.
interventricular, between the ventricles. Okay? And then circumvent, circumflex, oh. Think about the names. You mapped out the heart. We're talking about interventricular and around the heart. We're in the anterior aspect of it, so around the heart. So we're not only going around the heart, but we're going down the front of the middle of the heart. So, would medical terminology be the best class to take before this? Yes, it would, because what it does is it takes terms like this, and it breaks them down for you. So all you need to do is map the heart, like we just did, right and left atrium, right and left ventricle. You just have to map it, and then put your stuff in place. So if I said, and let's go with Amina. If I said interatrial septum, where would we be? Between the,
In the middle.
in the middle, between, down here again?
Top.
Up here?
Yeah.
Yeah, we would be right here. Interatrial, we're talking about the atrium. Interventricular, circumflex. Okay? So, remember, it's not about rote memorization. You can use rote to get the squares down, but everything else you have to think logically about. You have to say to yourself, okay, I get where this is going, let's think logically about it. Okay? That anterior portion of the heart. Now you know all the great vessels come out the backside, but we're not talking about the aorta or pulmonary or any of that. What we're talking about is coronary arteries. We're actually talking about the arteries on the outside of the heart. Now, arterial anastomoses. Arterial anastomoses. Now, this is by far one of my most favorite words to not only say, but also to learn. Anastomoses. Interconnect anterior and posterior interventricular arteries stabilize blood supply to cardiac muscles. What is it? Arterial, we're talking about arteries, arterial anastomoses. Anastomoses. How about this? Let's just clean the word up a little bit. Shortcuts, bypasses, side trails, Do those all make sense? What's a shortcut? If this is I-90 and it's blocked, where are you gonna go? Around, right? A shortcut around. Or maybe through a neighborhood. Okay, so if we have a main artery like I-5, what are two shortcuts you could take around I-5? 99 and 405. Those are anastomoses. Did they get us around I-5? Yes, they did. And now everybody's thinking about it going, hold it, you mean every day when I find a new way home because traffic's bad, that's an anastomosis? Yes, it is. Every time you find a shortcut, a new way home to avoid traffic, it's an anastomosis. You are bypassing the main route to get where you're going. And that's what they're saying right here. Interconnect anterior and posterior interventricular arteries, stabilize the blood supply to the cardiac muscle. So, you, all the way down the middle are the main artery. Everything around the outside is an anastomosis. So if I don't want to run right down here, I can do this. I can come over to you. I can come over to Mimi, right? Back to Lucy, and over to Train.